In this video, we're going to go over some more examples of the terms that I introduced in the last part of this video. But first, I wanted to recap these definitions right here. So, in a psychology experiment, the independent variable is the variable that's manipulated by the researcher to create the conditions that the participants experience. The levels of the independent variable are the specific conditions that the participants experience. And the dependent variable is the variable that's measured or recorded by the researcher to look at the effect of the independent variable. So let me give one concrete example to help you understand these definitions. So imagine that actually, let's go back to the experiment that I've been talking about all along as an example. So imagine I want to look at the effect of temperature on recall, and I randomly assign my participants to two groups. One group goes into the hot room, one group goes into the cold room, and I give all of my participants the same recall test, and then I compare the performance of the hot room with the performance of the cold room to see which group did better. In that experiment, the variable that I'm manipulating to create the conditions is temperature. When I set the temperature of one room to cold and the temperature of the other room to hot, I'm manipulating the temperature of the room. I'm setting the temperatures to what I want them to be. And when I do that, I'm setting up the conditions that will be experienced. So temperature is the independent variable. The levels of the independent variable are the two specific temperatures that I've decided to use. So if I decide that one room will be 60 degrees and the other room 80 degrees, then the levels of my independent variable are 60 and 80. And if I decide that one room will be 70 and one room will be 85, then my levels would be 70 and 85. So the independent variable would be temperature, and the levels would be just the two values of temperature that I've decided to use. And the dependent variable is the variable that I'm measuring or recording in order to look at the effect of temperature, which is my independent variable. So in this case, I'm recording a recall score from each person. I'm measuring recall so that I can then look at the effect that temperature had on recall. So my dependent variable would be the recall score in this case. So in an experiment, you have an independent variable that's manipulated. You have levels, which are the actual conditions, the names of the conditions. And then you have the dependent variable, which is measured to test the effect of the independent variable. And I wanted to quickly explain what I mean by levels. So in this context, levels don't have to be numbers. So I know in everyday life, when you hear the word levels, you think of like levels of a building that go from lowest to highest, or you think of levels as being something like easy, medium, hard. But in this case, levels don't have to be the levels don't have to be something that goes from the bottom up to the top. Um, so levels are just um, basically the names of the conditions. Think of them as just categories, basically. So the levels could be numerical, like 60 and 80 degrees, but the levels could just be just categories of something. So I'll give an example of an experiment in which the levels are just categories. So imagine that I want to look, um, imagine that I want to know if if the amount of questions that an audience member typically asks of a speaker depends on the gender of the speaker. And what I do is I randomly assign my participants to two groups, and I have one group listen to a speech by a male speaker, and I have another group listen to the same speech by a female speaker, and then I look at which group asks more questions of the speaker. Well, in that experiment, the independent variable is the gender of the speaker because that's what I'm manipulating. I'm I'm manipulating the gender of the speaker to create my two conditions. And the levels of the independent variable in this case are just male speaker and female speaker. Notice how the levels don't have a hierarchy in this experiment. They're just two categories, male speaker, female speaker. Like I said, the levels don't have to have a hierarchy. They could just be categories. Sometimes they do have a hierarchy, and sometimes they don't, depending on the experiment. And in that experiment, the dependent variable is the number of questions that each participant asks of the speaker, because that's what I'm recording to be able to then judge the effect of the gender of the speaker. Okay, and I also want you to remember that in a psychology experiment, the independent variable is just one thing, and that one thing has different levels to it. So in that experiment that I just described, you wouldn't say that the independent variables are male speaker and female speaker, because those aren't two separate variables. The independent variable is just gender of the speaker. It's one thing. And that one thing has two levels to it, which are male and female speaker. Here's another way to think about it. So gender of the speaker is something that varies, right? So it is a variable because it can vary to male speaker and it can vary to female speaker. But the names of the conditions, which are male speaker and female speaker, those two things are what they are. They don't vary. So they're not variables, right? They're just levels of a variable, right? So hopefully that helps you. Also, think back to my example about temperature. So temperature was the independent variable, and it's something that varies, right? It can vary from cold to hot. And the temperatures that I select, like 60 and 80 degrees, are levels of that variable. But remember, 60 and 80 degrees are what they are. They're not variables, right? So that hopefully that helps you see the difference between an independent variable, which is one thing, and the levels to that independent variable. So now let's just look at a few other examples. So imagine I do an experiment to look at the effect of temperature on recall, and I have a 90-degree room and an 90-degree room. We already talked about this example, so I'll go through this pretty quickly. And what I'm going to do now is just show you a few imaginary examples of psychology experiments. And in each scenario, I'm going to show you what the independent variable is, what the levels are, and what the dependent variable is. And if you like, you could actually pause the video and test yourself before I give away the answers. So we'll just go through this one quickly because I've already talked about it. So in this case, the independent variable is temperature, the levels are 60 and 90, and the dependent variable is recall. Now imagine I do an experiment to look at the effect of hours of sleep on exam performance. I randomly assign my participants to two groups. One group takes an exam after sleeping 4 hours, and the other group takes the same exam after sleeping 8 hours. So what I've done is I've actually told one group to sleep 4 hours and the other group to sleep 8 hours. And I've then compared the two groups on their exam performance to see which group does better. So try to test yourself on this one. And the independent variable is hours of sleep. That's what I'm manipulating. By telling one group to sleep 4 hours and one group to sleep 8 hours, I'm manipulating the hours of sleep of my participants. And the hours of sleep that I've selected are 4 hours and 8 hours. Those are the names of my selected conditions. So those are the levels. And the dependent variable is the exam score, because I'm measuring the exam score to be able to look at the effect that hours of sleep had on my participants. Here's another example. So now, let's say that I'm doing the same experiment, but now I randomly assign my participants to three groups. And one group sleeps 4 hours, one group sleeps 6 hours, and the other group sleeps 8 hours. And I compare the three groups on their exam scores. Now, I used this example, or I included this example, because I want to show you that an experiment doesn't have to have just two groups. It could have three or more, depending on the hypothesis that the researcher is trying to test. So all of the examples I've given you so far are with two groups, just so I can keep things simple, but it doesn't have to be two groups. It could be more than two. And this one does have more than two groups. So try to think about this for a moment and then see if you got the answers correct. So once again, the independent variable is hours of sleep because I'm manipulating that variable to create my conditions. The levels are 4, 6, and 8 because I've selected those to use them in the experiment. And the dependent variable is once again the exam score. So remember, if I'm trying to look at whether exam performance depends on hours of sleep, then hours of sleep, exam performance is dependent and hours of sleep is independent. Here's the one with the male speaker and the female speaker, which I already talked about. So I said that the independent variable is the gender of the speaker. That's what I'm manipulating. The levels are male and female speaker, and the dependent variable is the number of questions asked. So if the goal of my experiment is to look at whether the number of questions depends on the gender, then number of questions is dependent. So here, in example 5, I did an experiment to look at whether people drive faster in red cars than in black cars, and I randomly assigned my participants to two groups. And one group test drives a red car, the other group test drives a black car, and I look at which group drives faster on average. I record the speed of each participant. And this could be done in a real car, or it could be done in a simulator. So let's take a look at what the answers are. Well, the independent variable is the car color. I'm manipulating the car color by assigning one group to red and one group to black car. The levels are just the names of my conditions, and the dependent variable in this case would be the driving speed. That's what I'm measuring to collect my data. This is another example in which the levels don't have a hierarchy, they're just categories. And to wrap things up, I want to show you what the independent variable and dependent variable look like in a graph, like a line graph or a bar graph. I want to show you how they're displayed. So if you make a line graph or a bar graph to show the results of an experiment, the independent variable goes on the x-axis and the dependent variable goes on the y-axis. So here I have my independent variable of car color. I have my two levels, which are red and black, and my dependent variable is plotted on y. And what I'm plotting here is the average driving speed of the red car group and the average or mean driving speed of the black car group. And that's why people sometimes refer to the independent and dependent variables as just being x and y. That's actually a short way of talking about these variables. So instead of saying independent variable and dependent variable, you could just say x variable and y variable, as long as the person that you're talking to knows what you're talking about. And I mentioned that the purpose of an experiment is to test the effect of the independent variable on the dependent variable. So in my temperature experiment, I would be testing the effect of temperature on recall. In my car color experiment, I'm testing the effect of car color on driving speed to look at the effect of car color on driving speed. So the purpose of an experiment is always to look at the effect of an independent variable on a dependent variable. And the graph that I just showed you displays that effect. And The effect of the independent variable can be seen by looking at the difference between the means of the conditions. So let me show you what I mean in a visual example. So here we have the mean driving speed of this group, and here we have the mean driving speed of this group. And this difference right here is the effect of car color, right? Because if this difference is statistically significant, we're going to conclude or infer that the red color caused this group to drive faster, and that effect is the effect of car color, right? The fact that this group drove more quickly on average is the effect of car color. And if to be 100% accurate, you would need to say that this difference right here is the effect of the independent variable plus chance factors, because this difference between the two bars is going to be, well, the size of the difference is going to be affected at least somewhat by chance factors like fatigue or sleep deprivation, or one group having a little bit more coffee than the other, one group being a little bit more anxious than the other. So this difference right here is the effect of car color. That's what we're inferring. That's what we're inferring to be true based on these results. But the size of the difference is going to be affected at least somewhat by random chance factors. So yeah, so this is how you look at the effect of the independent variable in a bar graph. So this wraps up this video, and if you have any questions about this topic, just let me know.